Hello friends, welcome to the video tutorial on Firebird V Robotics Research Platform. This platform is based on Atmega 2560 microcontroller, which belongs to the AVR architecture based microcontroller family. In this tutorial, we will introduce you to Firebird V Robotics Research Platform. Now let us see the agenda for discussion in this tutorial. We will discuss the major components that make a robotic system. Then we will see various versions of Firebird V Robotics Research Platform. We will then discuss the major components present in the Firebird V Atmega 2560 based platform and hence understand the capabilities of the Firebird platform. So, what are major building blocks or components needed for designing a robot? The first component is sensor. So sensors are devices which allow the robot to sense the environment around it. Sensing devices can be used by robot to see if path in which it is moving is clear without any obstacles. Or sensor can be used by robot to calculate the temperature of its environment. Considering robot as analogous to we human being, sensors are devices that make robot feel the world as we human do with help of our 5 senses. So we will discuss more on this after few slides. Moving on to the next component, which is the actuator. So actuators in robotic system are analogous to human feet and hand, which help human being in locomotion and performing all sorts of tasks. In robot, actuators can be motors, which can be a DC or servo or stepper motor, or can be a hydraulic or pneumatic system, which help robot to move, pick objects and perform many other such tasks. The third major component is the control system of the robot, which is the microcontroller or processor of the robot. This is the brain of the robot which takes input from sensors or other medium and take decision on the task to be performed. The decision taken by the robot is because of the intelligence of the robot. The robot is made intelligent by the code we write into its memory. So in a way, intelligence of robot depends upon the intelligence of its master, that is we who program it. The better you code, the better your bot will perform. Moving to the next component, which is the power supply. This is the key component without which the robot can never start, just as we human can't do without the food. The last major building block is the communication system. Just as human being can talk or use sign language for communication, robot also needs communicating device so that it can send and receive signals from human or other robot. Now we will discuss Firebird V Robotics Research Platform and analyze features of the platform which makes it suitable for being called a robot. So what actually is Firebird V Platform? Firebird V is a robotics research platform designed and developed at ERTS Lab in Computer Science and Engineering Department of IIT Bombay, with a vision to teach embedded system and robotics with a practical approach. This platform is used at IIT by UG and PG students to do lab work and make their course project. Besides this, IIT is using this platform to train students and faculty of various engineering colleges throughout the country through Project e-Yantra. e-Yantra also plans to take this platform outside IIT and give students throughout the country an idea of what robotics is about. This platform is also used to analyze various problems and solve them using the platform at a prototype level. So Firebird V comes in various flavors. For example, the first platform has 8051 core based NXP manufactured P89V51 RD2 microcontroller. Second configuration uses AVR architecture based Atmega 2560 microcontroller. And the third configuration uses ARM architecture based LPC2148 microcontroller. So basically all platform uses different microcontrollers which gives different processing capabilities, and as a user we have freedom to select any one of them. Now let us see overview of each platform individually. Let us look at P89V51 RE2 based Firebird V platform. So this is how the board looks. So all Firebird V platform has two PCB. You can see your robot. The bottom PCB is the main board which has various circuits and other components. The top layer, called as daughter board, is the board which has the microcontroller. In this platform, we have Philips manufactured and 8051 based microcontroller which is called as P89V51RD2. The second platform is Atmega 2560 based Firebird V robot. So as you can see, this looks similar in structure as P89V51RD2 based platform. So as I said, all platforms has two PCB. Bottom PCB is same and top PCB or the adapter board uses Atmel manufactured and AVR architecture based Atmega 2560 microcontroller. So this platform is slightly advanced and provides more feature as compared to 8051 based board. We are using this platform and will learn more about it as we progress further. The third configuration is LPC 2148 based Firebird V robot. So this platform uses ARM7 architecture based LPC 2148 microcontroller. It is a 32-bit controller and provides even more functionality as compared to previous two platforms. So one can switch to this platform after learning basics of controller. As we have discussed earlier about basic building blocks of any robotic system, we will now consider Firebird V platform and see each building blocks in details as present on this platform. So let us look at the sensors present on Firebird V platform. First is the sharp IR range sensor. This sensor is used for measuring distance of any object from the robot. It has an infrared emitter which emits infrared light and a CCD array as the receiver. So when an object comes in front of the robot, infrared light emitted from the sensor strikes the object and is reflected back. This reflected ray is received by the array of CCD at receiver side. So a triangle is formed with emitter, object and receiver as three vertices, and depending upon distance of the object, the angle between incident ray and reflected ray changes. This change of angle gives the distance of any object in front of the robot. So the major advantage of this sensor is that it does not depend on color of the object. Even if small light is reflected from the surface, it will be received by the receiver, and hence angle can be found and distance can be calculated. This sensor is available in various range. The commonly used have range of 4 to 30 cm and 10 cm to 80 cm and are called as GP2D120 and GP2D12 respectively. Beside, there are other range sensors also available. The selection depends on application you are using it for. On Firebird V platform, we can attach 5 such sensors. Positions for placing these sensors are shown in the figure. Next sensor is known as IR proximity sensor. This sensor is also used for distance measurement or can also be used for object detection. However, the range of the sensor is very small. It can measure distance only up to 10 cm. These sensors also have an IR transmitter which emits infrared light and uses phototransistor as receiver. These sensors can be used in conjunction with sharp sensors for better resolution. On Firebird V platform, we can attach 8 such sensors. Position for placing these sensors are shown in the figure. Next, we have white line sensors. As the name suggests, these sensors can be used for sensing white line. This sensor has red LED as emitter and phototransistor as receiver. Working of this sensor can be explained using a very simple physics. That is, the black surface absorbs all light incident on it, whereas white surface reflects light incident on it. So phototransistor receives different amount of reflected light at black and white surface, and so robot can make out whether it is on black surface or on white surface. Array of 3 white line sensors are provided with the platform. However, array of 5 and 7 white line sensors are also available and can be interfaced easily. Its location on Firebird is shown in the figure. Moving on to the next sensor, we have position encoder. These sensors are used for measuring the distance robot has moved or the angle by which robot has rotated. This sensor has IR LED as emitter and phototransistor as receiver. Beside, there is a slotted disk assembly which is placed between the transmitter and the receiver. The slotted disk is connected to the shaft of the DC motor. Whenever the motor rotates, slotted disk also moves. Now, when the slot is there between the receiver and the transmitter, IR light will be received by the receiver. But when disk comes in between the receiver and the transmitter, IR light will not be received by the receiver. So we get a pulse high and low depending on whether disk or slot is between the receiver and the transmitter. By counting the pulse, we can measure how much the DC motor has rotated and accordingly what is the distance moved. We will cover programming of this in the video tutorial for interrupt, where you can get clearer picture of this. On Firebird V platform, two position encoders are present on both the DC motors. Next we have infrared TSOP receiver. This sensor is used when you wish to control the robot using TV remote control. Remote have IR LEDs and this sensor has a phototransistor. So when you press button on remote, that can be received by the robot using this TSOP receiver. We are using TSOP 1738 on the platform. On Firebird V platform, one TSOP sensor is present. Position for the sensor is as shown in the figure. Next we have servo mounted sensor pod. This is an add-on module and not present on Firebird V platform. This pod can be used to mount camera or sensors. It has two servo motors attached so we can have pan and tilt motion. This module can be used for things like room mapping or tracing objects and various other applications. Next we have accelerometers. This also is an add-on module and not present on Firebird platform. Accelerometer gives acceleration of object in 3 dimensions. In market, accelerometers are available which can give acceleration either on 1 axis or 2 axis or 3 axis. So depending on it, accelerometer can have up to 3 output pins which can be interfaced with the platform, and accordingly readings can be obtained and computed according to the need. Next we have gyroscope. This also is an add-on module and is not present on the Firebird platform. Gyroscope provide angular velocity of the object. These sensors can be used for maintaining the orientation of the object and hence maintain its stability. Next we have ultrasonic sensors. This also is an add-on module and is not present on Firebird platform. Ultrasonic sensors are used for object detection and distance measurement. One can easily interface this on the robot in the slot provided for this. This sensor can be used as an alternative to sharp sensors. Next we have motion sensors. This also is an add-on module and is not present on the Firebird platform. The passive infrared motion sensors are used for detecting live object. These are found in places such as office or washroom where lights and fans are controlled depending on whether someone is present or not. These sensors can also be easily interfaced on the Firebird platform. Next we have GPS or global positioning system. This also is an add-on module and not present on Firebird platform. This module, when interfaced on robot, can give the location of the robot by receiving signals from the GPS signal. It gives location in terms of latitude and longitude. So we have discussed some of the commonly used sensors. Few of them are interfaced on the Firebird robot and ready to use, while others can be purchased from the market according to the need of the application. Also, beside the sensor I have mentioned, you can interface lots of other sensors also with the platform. Now let us move to the next major component, which is the actuators. For actuation, you can use DC motors and servo motors. Two DC motors interfaced with the platform. These DC motors are connected with the wheels of the robot. DC motors are 60 RPM motors. You can attach two more DC motors to the platform. The driver ICs are present on the robot. You can refer to hardware manual of the robot given in the DVD for getting the port and connection details. Talking of servo motors, you can attach up to 3 servo motors to the robot. These servo motors come handy if you wish to make some kind of arm or gripper structure on the platform. Servo motors are add-on module. You need to purchase it from the market. Coming to the control system of the robot, microcontroller is the main control unit of the system. So in this case, controller used on the Firebird platform is Atmel manufactured AVR architecture based Atmega 2560 microcontroller. Next, let us see what makes robot intelligent. So as discussed in the first slide, intelligence of the robot is the user written code. So we write code in embedded C language, which is similar to the C program with slight modifications to make language suitable for accessing hardware connected at controller pins. Also, the code we write in C language is not understood by the machine. So we have to convert the code into a machine language, which we will call as hex. We will learn how to compile code, generate .hex file and load it into microcontroller's memory when we start writing the code. A reference note is given in the documentation DVD with the video tutorial, which explains the process. We will see how to write code in another tutorial. For powering the system, we have two different modes for powering the robot. First is battery powered. A nickel metal hydride battery of 9.6 volt and 2100 milliamp is given with the robot for powering. Second mode of powering is through auxiliary power. A 9 volt 1 ampere DC adapter is given with the robot for powering the robot. You must read the hardware manual to get used to both these sources. It is also very important that you power the robot only after reading the instructions in the manual. Using power source in a wrong way can permanently damage the robot. Next is the communication standard. So communication can be done in two ways, either wirelessly or wired. So wired communication is done through USB cable or through RS-232. Since RS-232 port is not present on the laptop and system nowadays, so a USB to serial converter can be used for the communication. We will use USB communication through a USB cable supplied with the robot as main source for communication between the system and the robot. It will also be used while you are programming the robot, that is loading the .hex file into the flash memory. Wireless communication is done using Zigbee module. Zigbee is based on IEEE 802.15.4 protocol. Connection channels for Zigbee module is present on the robot. But Zigbee is an add-on module which you have to purchase from the market if needed. Communication through infrared TV remote is already explained and can be considered as a wireless way of communication between the robot and the human. Now, indicating devices are the modules which will be helpful to the programmer while debugging. So indicating devices present on Firebird platform are: first is 16:2 alphanumeric LCD, which is present on the robot. Then we have a buzzer and then a bar LED. All these devices are present on the robot and are programmable. In this slide, I have shown the block diagram of Firebird V robot. We have already discussed these in the slide, and so this can be used for reference and overview. So here we have shown microcontroller Atmega 2560. Through the controller we have connected position encoders, white line sensors, sharp sensors, then 5 IR proximity sensors, then 3 servo motors, 1 LCD and 1 switch is also interfaced with the Atmega 2560 microcontroller. As I have discussed in earlier slide, you can connect up to 4 DC motors, for which 2 motor drivers are already interfaced on the platform. Buzzer and bar LED are also connected to the microcontroller. For communication, as we have discussed earlier, Zigbee is connected, RS-232, USB communication and TSOP is also present. Then another important feature in Firebird is the slave controller. Slave microcontroller is used in case when all analog channels of masters are exhausted and you want to connect more analog sensor. So you can do it by connecting the extra device to the slave controller. Slave controller will get signal from master controller and it will perform accordingly. In case of Firebird 52560 platform, Atmega 8 is used as slave controller, and 3 IR proximity sensors and 4 white line sensors are connected to it. So we have understood the capabilities of the robot and have seen various features of it. However, this platform is huge and understanding all of it at once is difficult. So I suggest you to use the hardware manual throughout the use of robot. With this, we have come to the end of this tutorial. Thank you for listening. For any queries or doubt, you can visit http://qa.e-yantra.org. This is Saurav Sandalia signing off.